Welcome to Maven's Talk series. This session is about eliminating toil. Programmed by Digitarati, India's first IT finishing school.
Today we are going to focus on eliminating toil, a very interesting topic, a topic which touches everybody because of the kind of work that we are doing into IT. So here, the way I kind of see how a toil can be eliminated, before that, maybe a kind of insight that what would be the focus of SRE, right? Not this, not the definition, but typically the focus. So this essentially, if you look right, is actually a four-step approach in my opinion. The first is that the SRE has to focus on the reliability part, right? Where he needs to ensure that the services that are being provided are fairly reliable or perceived reliable by the users. It can only be perceived as reliable once you are defining what is the objective of the services that you're providing. And hence it is important that we define what is the service level objective, and not only define but actually make it visible by having an indicator named as service level indicator, right? And then once you define the service level objective and SLO and SLI, then it is also important that while you are planning to meet the overall SLO of 99.99%, the other way to look at it is what can I lose? So what you can lose is only 0.01%, and converting that into minute is actually your error budget. Every time when you try and think about what can you lose and what is left over from your budget perspective, like we all have our salaries and then we decide how much to expend, apart from the fact that most of the time credit card really spoils us. So that's is actually an error budget. And then last but not the least is the team itself, right? That typically how you are ensuring that everything that you are delivering is actually also the objective of the team. And one of the objective is that while I'll ensure that I'll deliver SLOs and SLI, but the kind of team construct, an ideal team construct, is that every SRE personnel need to spend 50% time in break fixing the issues that they see on a day-to-day basis, and 50% of the time in identifying how can the product become more futuristic, how can they continue to make it more attractive, make it more personalized for the user. And that is where the concept of toil comes into the picture. And before we proceed, the best way to understand how to eliminate toil is when you have answers to four of these questions. The first question itself is, what is toil, right? There are a lot of common misperception about toil, and we will kind of deep dive on it today. And I will share you my views on what do I think is toil, and that is largely also aligned to bigger organizations like Google, who have really incepted this in the IT world. Second is, we need to understand, is the toil really we need to eliminate, right? Because a couple of times you need to take a call whether you can live with it, and we'll kind of see what it means. And then when we have really done the groundwork of identifying what is toil and whether we need to really eliminate it or not, then we should think about how do we eliminate toil. And then last but not the least, why toil elimination is really necessary. And until and unless we do not have the answers to these four questions, it is very difficult to identify what would you do with the toil, right? So we'll quickly get started, and I'll try to deep dive into it. So from a definition perspective, broadly, toil is considered to be the set of activities which are manual, repetitive, automatable, tactical, and really which are non-value add tasks. Now let's look at some of those examples. And running a script manually is like you already have a script and you're actually running it manually, that is considered to be a toil. Manually resolving a similar issue for the second time is actually not a toil. It is a toil maybe once you're doing twice or even thrice or even more than that. Developing a unique solution for an existing issue, which is what most of the time our problem management friends prefer, and then our architects and really form a unique solution, is not a toil. Performing a task manually, which is can be automatable, is a toil. Performing a task manually which needs a human judgment, you can't really do that automation, because you need to have somebody look into the logs and then get the insights and then take a judgment on what needs to be changed, is not a toil. If you have worked, and this is interesting, if you have worked on break fixing an issue, and after 3 hours of you investing so much of time, the service status remains the same, it is a toil. Reviewing the legacy codes, which would help you identifying the root cause of a service interruptions, and then for you to take in action, is not a toil. And last but not the least, if your task is scaling, today you have got 10 applications and maybe X number of features in all of them, and if at all that increases to Y, and then if you are really scaling the team to take care of it, then that is also a toil, because that's where you are really not using the power which is really needed to get the best out of things, right? So this is, I would say, the broader context. That's the broad underlying definition part. Now the second part is typically, which is very important, is we need to understand that do we really need to eliminate the toil? And the best way to really think about it is, just look at this picture. When we were in theory, the way we see how we write code, work on the original task, and then we think that the automation will take over, it is more like a typical curve. But when we kind of go ahead and look into it on a reality, then there is debugging, there is back and forth reviews, feedbacks, and then there is an ongoing development. So then there is a big difference between what we assumed in theory and what exactly is in the reality. And the reason why I have brought this up is, when we are thinking of eliminating a toil, it is very important that we think it from a realistic lens and realistic frame. And why this is important? Because ultimately, when you are going to eliminate a toil, you need to create a balance between the effort that is being invested right now and between the time, money, and the effort that you are going to invest to reduce the toil. If at all a 10 seconds or a 30 seconds or a maybe 1 minute of task that can be really done without too much of effort right now, and hence if you are investing 20 hours or 30 hours of worth of effort in kind of developing an automation script for that, then that is not the right way to address it, right? And hence the ROI would always be a questionable thing. There are other benefits that we needed to think about while we are going to think about whether we need to really eliminate a toil or not. So one is definitely, once your project is growing over time, and then if you would like to kind of see that some of those activities should get really reduced, and that is in line to the last thing that we had in our definition, is as and when you are scaling up your task and activities, then the number of people that you are deploying should not be in a direct proportional, and hence effective reduction of toil is important, and hence this is an important benefit which most of the organizations also adopt. It is also very important that nobody likes doing the same thing over and over again, right? And we have seen that instead of asking people to do the same monotonous thing over and over again, it is important that we eliminate toil so that everybody thinks about putting up their brains, putting up their thoughts on how to solve the complex problem, and that's where the team morale really increases, and to a certain extent helps in controlling attrition and also reducing the burnout rate of the team. One thing is also very important is a lot of times, when we are working on, simple and monotonous things which are kind of daily basis, and there is a lot of context switching, right? You are working on email and then you are kind of switching to a ticket and then, reviewing the code and things like that. But if you are really focused on one activity, which is more about you identifying a root cause and fixing it, then basically the context switching is less, and hence this really helps to increase the team productivity. So overall, these are some of the ways which would really help you to define the overall objective of maybe creating a business case when you are thinking about eliminating the toil, and that would really being able to help you to eliminate it. Now let's think about how do we think we should eliminate the toil, and I think this is something which is my fundamental way of how I think about it. See, when you are thinking about eliminating a toil, then a lot of times people just come and think about that automating the task is the only approach. In my mind, this is not the best way. The first thing is you needed to think about is how do I ensure that the task that you are doing is completely eliminated. That means if it is automated, that does not mean that the problem is solved. In any form, an incident is an overhead. In any form, wherever something which needs an attention and is a break fix situation, it is an overhead. And hence the mindset that we should adopt is basically an eradicate framework. That means you completely eradicate it, at least try and attempt to eradicate it. And I honestly, I'm sorry that I cannot really think about some words on dictate, and hence I thought it is a good way to remember eradicate. And E stands for eliminating, where you eliminate that particular ticket would not happen at all. And I'll talk about a couple of examples to ensure that I bring that concept to the table. The second is if you're not able to eliminate, right, then think about how do I work upon reducing the impact. So incident will still happen, but at that point of time, you know that you have been able to successfully reduce the risk. And hence, if a risk is reduced, then think about that a P1 incident becomes a P2 or maybe a P3, and hence the business interruptions are reduced a lot. That is the second priority for us to think about when we think about eliminating a toil. And last is when you think that you cannot really eliminate it, when you think you can reduce it, and then a couple of tasks would be where you can't do anything about it. So the ones that you're trying to reduce it and the ones where you can't do anything about it, those are the potential candidate for automation. And those activities should be considered for automation, and we'll deep dive on all of them in a moment, should be considered for automation. Jumping from an automation to resolve or eliminate toil is a blunder, and we should really avoid it. I mean, in my 18 to 19 years of experience, I've seen this as a common misconception, and hence it is important that while we are talking about SRE, it is very important to understand that we're talking about reliability, and reliability cannot really come from an automation per se, right? So let's look at few of the examples. One thing which would touch to a lot of the application people in their day-to-day activity is latency in accessing the application, either hosted in data center, DC stands for data center, or hosted in cloud. And I'm sure this is a common example. I've just drawn a picture so that you can understand it pretty well. Think about your bank branch, and then people are accessing a CRM or maybe an SAP or a Salesforce.com from the branch, and then it is typically hosted in your data center. And as we know, the way the entire architecture really works is that you have the MPLS network, and through the MPLS network, the branch people really access the application which are hosted into data center. Now, this is a very common example, and I've seen this across multiple organizations. The problem statement that I have found at least around 10 plus clients is that there were slowness, and the way they were trying to solve for this is the following. First, the focus was only on the network layer, right? Everybody was bent on increasing the bandwidth of the network, and they have really spent a lot of money in increasing the bandwidth to 3 times in maybe 8 9 months, because the bandwidth was not that, according to them, was not that great, and hence they have increased the bandwidth. But typically that has really not solved the problem, because here they were trying to reduce the impact, and actually the classic problem is that there was an elimination needed. And how did they think about doing this is, there was, and I'll not talk about the approach. So what the approach that they did was, first of all, the view that has to really think through is, when you are talking about an issue, you have to take a global view of whether this application accessibility is a unique problem for specific branches, or is it a common problem for most of the branches. You should think about it, because it is very important that the branches, maybe an asset or a liability branch is configured for a different, because that the application accessibility, the application which was being accessed from the data center by the bank branches was really slow. And hence a lot of times, when we try to solve this problem, we kind of try to look at from a network layer perspective, and I think that might not be the best way to handle it. And I've seen a lot of times people have gone ahead and increased the bandwidth of the specific branch, which was the MPLS link connecting from the branch to the data center. But believe me, that has not resolved the problem. And then what we said was, we kind of did a global overview that whether it is a common problem, or whether it was a really isolated problem for a few of the branches. And hence we have identified that yes, it was a common problem, at least for 75% of the branches. Then what we went ahead, we have actually did we have went ahead and looked into the application architecture. And what we have identified, that for a small task, there are too many transactions that were happening from the application, from the branch towards the data center, and that was one of the reasons why the network bandwidth was getting choked. So that means the application architecture itself was not into the very modular way, and not into the very optimized transaction way, and that was the reason. And hence what we were trying to do, we were trying to reduce the impact by increasing the bandwidth of the network, and hence the problem was not really resolved. But when we have really looked into it by uniquely testing the branches, asking them to do a couple of things, for example, submit the profile of the application into the CRM, and create a new user into the CRM, and all of that task, then we have identified how the network is performing. And that has really given a way that, see, we needed to look it beyond the infrastructure layer and go to the application layer. And that is where this problem was identified. It took a long time, right, for us to identify that problem. And then the other conscious call that we took was, we kind of went ahead and have started doing the changes into the application architecture in a modular approach, one by one, feature by feature. And then once we were able to reduce the number of transactions, then the network bandwidth that was excessively utilized, around 80 to 90% before, has actually came down to 20 to 20%, right? So this is where a reduction and an automation would really not have helped, but an elimination approach have really helped, and hence we have adopted it. But then we identified that since the branch was increasing, so the second steps that we took was, then we identified after, let's say, because the number of features were increasing into the application, the number of people into the branch were getting increasing, the number of footfalls were increasing into the branch. It was typically an asset branch, and hence what have we identified, that now when we have looked into the network performance again, it was again reaching to 80 to 85%. And now this was genuine. So what we did was, we have kind of did a network load classification that is called as QoS. So where you mark a specific class of a traffic. For example, if it is a critical traffic is basically for some of those high critical applications, then we have given it a priority 1, and then other traffic, like for example your Office 365 traffic and other applications which are of low priority and low tiered applications, were given a priority 2. and therefore that has addressed it. But then after a year, we have again found that the network utilization was really growing. So then we identified that, look, now we needed to think about an architectural change, because ultimately a lot of applications were also on cloud, and the way the entire traffic was running was, it was going from branch to the data center, and from data center it was connecting to the cloud, which was not the best way to really look forward to address this challenge. And hence the approach that we adopted was, I adopted an SD-WAN technology. And what it has really done, that using the SD-WAN network, the first thing that we got to know was that we were able to make the application traffic tiering, or rather classification, becoming more dynamic. So earlier it was static, that every application wherein you want a priority classification to that certain class of traffic, that was a static, and now it is dynamic. So wherever the load increases, that is automatically being scaled, and hence it ensures that all that traffic is being passed through while the SD-WAN got implemented. The second important thing that has happened with SD-WAN was that the applications which are hosted on the data center continue to go via MPLS, but the applications that were hosted on cloud, there was a local breakout that was given from the branch to the cloud, and hence it has avoided going to that data center or backhaul to data center, and then from there it going to the cloud, and it has reduced the latency to a large extent. And along with that, what we have seen, that typically the percentage of bandwidth increase, which was happening 20% almost on year-on-year basis, and that means on a 5-year basis, it would be 100% of the network bandwidth increase that would happen. That has got reduced. That over 1 year, we could just see that there is 4 to 5% of increase into the network bandwidth, and also the cost of network bandwidth has been reduced, and the applications architecture has really eliminated this issue, and now we don't get any tickets on the application related issues. So it was a long journey, but I mean, the reason why I brought this example, because one of the classic which is being handled, or which is being faced by most of the bank, and this is the best way to kind of address it. So this is one thing which I would kind of suggest on an elimination perspective. Now the second example which I have is, how do we understand what is the R of eradicate, which is reduction, right? So what you need to think about is, the best way I could think about is that we as an organization, or we as an IT team, always see that the vulnerabilities into our environment are increasing a lot. And second thing is, the fragmentation that is there in our environment is also a lot, right? So vulnerability, I'm sure you guys know it. There are OS application and all those level of vulnerabilities that are either being seen by your information security group, and then possibly they would kind of ask you to take care of that vulnerability. And the second is the fragmentation, which essentially means that within your environment you have multiple OSs. Within different OSs you have multiple different versions. Believe me, that is a risk. And if it is a risk, then the only thing that you can think about is reduce, and that is where the R of eradication really work through. So I mean, one thing which I could think about is, when you identify the risk that carries within your organization, then it is basically the number of vulnerabilities that are open and the action that you need to take, and hence a risk score can be really identified. And now this risk score is actually a risk, because couple of times, if there are malware attacks or any such a kind of cyber security threats, and if at all your vulnerability is open, and then that it is really an impact that can impact the reputation also of an organization. And hence it is important, and the only way to get away with this is have a plan, and also identify how do you reduce the risk, right? So hence this is an example of reduce. Let me tell you what I think would be the best way. So the way you kind of work on the vulnerability is typically, you get a sense of all the vulnerabilities that are open for you, but then you cannot really, have engage the team to solve all of them. First of all, you'll have to scan it and then identify whether it makes sense to you or not, and then possibly take an action. You can't really, close all of them, right? Because you have your operations load, and you have your, change management, your new features getting deployed, and things like that. But the way to look at it is basically classify the vulnerabilities, right? Critical, medium critical, and maybe low risk. And then have a plan that within 30 days you will address the critical ones, within 60 days you will address the medium ones, and maybe after 60 days you will address the minor ones, which will typically not have an impact. That's one way to look at it. The second feature is also important, is make your environment as less fragmented as possible, because believe me or not, a lot of times the number of vulnerabilities that you get is also directly proportional to your environment. If you have 5 different versions of Linux in your environment, then that means you will get 5 different type of vulnerabilities, right? So forget about how would you automate it, but think about the risk that it carries and the effort that you will have to invest over and over again for this kind of fragmented environment. And hence a proactive release management is an opportunity that has to be availed, so that it really helps to reduce the risk into the IT environment and make your environment less risky and less error prone. So this is a perfect example of how do you reduce the risk and also reduce the effort that an SRE team would have to anyways invest. Maybe if a P1 or maybe comes in, and hence they needed to kind of work on it. So this is a proactive approach which should be adopted. The second example is, now we are done with E, we are done with R, we are now at A. And this is fairly straightforward. But here, instead of examples, I would like to talk about the approach, right? When you think about automation, it is not just a lift and shift, right? You think about creating, in how do you automate an activity, or maybe a task, or maybe an end-to-end automation. I think the way to look at it is basically, how do you create a framework of automation? And then that can be best achieved when you identify where you are. And the way most of the organizations have really thought about automation is, first of all, the journey of automation has to get started with your foundation, right? Which is where the team on the ground should be able to very, very clearly identify that whether they know the activities that are being repeatable has to get automated, so that that awareness spreads. And then some of them are really good into scripting, right? Maybe a PowerShell script, a Python script, and so on and so forth. And that lays the foundation of really discovering, identifying, and also solving that problem. So that is the first way. The second is typically bringing in the flavor of robotics process automation. Nowadays, that's also called as intelligent automation, wherein you are doing a shift left. And now what does a shift left means? From your L3 to L2 and from your L2 to L1. But beyond L1, we do not think about anything else. And here the extreme shift left is basically your RPA persona, which basically picks up the task beyond L1 and then try and automate it, so that there is no effort which are being invested at all by the team. Then basically, so now RPA would typically do something which is very, very plain and simple, right? The SOP is known, the steps are known, and hence you can really, really automate it. Typically mimicking what your engineer is doing and then kind of trying to automate it. But then what is beyond, right? So the beyond is basically your cognitive brains. So how would you then apply the flavor of, and by the way, when you are basically, I mean, if I have to kind of make it a time-based journey, then the foundation, if you're really starting, then it has to be almost 0 to 3 months. And the robotics process adoption has to be from the 3 months to at most 6 months. So that means you're now in the 9 month of the journey. Virtual agents and analytics is one thing which is now you are gaining an insight of the data that you have, and then you are taking an action. I'll tell you one of the coolest thing that I came across is, a lot of times we always think that when we are working into an application development related space, then the only thing that we can think about automation is the testing. And that's a very, very fairly common misperception. But in my mind, I think there are a lot of other tasks that can get automated. For example, think about automating a requirement getting converted into the test case scenarios, right? Which is normally done by your QA team, and hence you are converting that requirement from the requirement itself to the test use cases scenarios, and the creating the test cases out of it, and then executing those test cases to ensure that it is all taken care of. It is very, very common, not very common, but at least maybe would become very common soon. And hence this is where a combination of analytics and virtual agent is important, and hence this can be very can be one of the use case that should be there in your library, and you should think about automating it. The other part is, a lot of times we kind of focus a lot of our energy or spend a lot of our energy in doing a lot of reporting stuff, right? For example, what is your productivity, what is the progress of your project, right? How many defects you have, and things like that. Now with the with the evolution of ELK, with the evolution of visualization tools like Tableau, ClickView, this can quickly get integrated to your Jira, or in fact, you can create dashboard within Jira itself. And we talked about Confluence, I think almost 1 to 2 months back. Those kind of visualizations can be created, and hence a lot of your effort in terms of you spending time in giving statuses and report can be really backpassed to descriptive analytics, and hence can be very clearly automated. So that's again another good example of how can you do it using analytics. The other example is typically from a virtual agent perspective. You are gaining knowledge from the overall environment. For example, if you're doing an application development and you are seeing that you have a project which has to get delivered in XYZ days, and hence backhauling it and backtracing it to identify what is the tasks that are becoming a constraint to not allowing you to deliver it within the timeline is one thing which is coming in the form of an assets. And the closest answer that I can think of how this can get adopted is, I've seen some of the coolest thing from digital AI. What they usually do is they kind of integrate all of your tools like Jira, Confluence, wherever you have the information, and then they create a live dashboard for you that these are the bottlenecks for you to meet your targets. These are the modules which are running really slow. These are the modules where there are a lot of errors and hence need focus. And they also learn from the past a similar project and then bring that learning back to those projects. So a lot of such things where project managers usually deploy a lot of time gets automated, and hence the time, or rather this is also a toil, can get eliminated by bringing in those level of technologies, right? Now the last but one of my favorite is the artificial intelligence. I mean, to be very honest, artificial intelligence has been one of the most talked about, technology at present. But the way we think about how an artificial intelligence can really bring a lot of benefit to the organization, I think that information is not really known, and hence I would like to kind of talk about that how an artificial intelligence can really help. Let me give you a couple of examples, right? So a lot of you would really do or work on a lot of changes, right? Maybe you're kind of thinking that a feature has to get upgraded, right? Or maybe any kind of infrastructure upgrade or any kind of changes that you are planning to do in your environment, be it the app layer or an infra layer. But what we've seen that a lot of times the change failure rate are above 1%, which is a hint that there has to be something done on the change management layer so that you are able to control the changes and able to avoid the change failure, and hence make sure that all those maybe major incidents that we see get from a change failure are really high. So there are a lot of development around predicting a change to be failed, and how it is done, that they basically look into the past records of incidents that were created because of a failed change. It looks into the architecture, it looks into the correlated information of a change in one element can cause an impact on the other element, and so on and so forth. And this data is typically used as a learning module for the AI algorithms to understand how can it learn and then predict before a change is being implemented. And this is really a great input for your change advisory board, that this can get automated to this can get predicted at a very high accuracy of around 85 to 90%. And then imagine that it can tell you, and not only this, right, it can tell you that this would get failed, but along with that it will also tell you that how can you reduce the impact of a change getting failed, or how can you avoid a change getting failed by focusing on these 8-9 things, right? So this is the power of artificial intelligence. Another example, we have our monitoring systems, right, which we kind of see that the monitoring systems typically work on monitoring an availability alert or monitoring a performance based alert. But availability alert is where something goes down and alert goes into the system, and hence, somebody works on it. That is something you can't really avoid. But think about the performance based alert, right? An application is working slow, latency into the application, and all, maybe there are some long running queries into the database. There are, slowness in your server response, and all of these are basically your uh, performance parameter. A lot of times these kind of things are really configured manually by a threshold into your tool. And so what happens, whenever this threshold is breached, then the alert gets triggered into the system and an engineer usually work on it. Almost 60% of such architecture of monitoring systems generate either a true positive or a false positive alert. By true positive, I mean that the threshold is really breached, but then the action that has to be taken on that alert is really not that. There is no action, rather. The reason being, it is the behavior of an environment. Think about you're in office where a lot of you, usually come at around 9:30 to 10. So then the network utilization of that branch is likely to go high at that time. And hence, if at all it is reaching 85% at that time and not others, then you don't really need an alert, because that's the behavior of your employees, and hence they get to work at around 9:30, and that's the behavior, and hence you don't need an alert. And like this, there are a lot of such instances which, if get investigated at a data level of what is the problem, then we identify the problem is the static threshold, because we don't have tools which can really look our data, and then rather at static threshold they basically define a dynamic threshold. And hence this is where the power of artificial intelligence really brings in. So I have seen, tools which basically look into your data. It really identifies the correct threshold at an hourly basis. So maybe from 12 to 1, maybe from 9 to 11, the threshold for a network alert is not 85%, but maybe it is 95%, because that's the normal way a business has been behaving for so long. And hence, almost 40 to 50% of alerts can be eliminated, and the remaining ones can be automated by, by triggering, a script or anything of that sort to make it happen. So I think I talked about a lot. Let me kind of show you maybe an example of how this should really look like. And also what I've normally seen, that you can really automate by following these 3 4 fundamentals, and the way I've described the roadmap, and you've kind of achieved almost 15 to 20% of effort gain or productivity gain by doing all these automations. And then there are a lot of categories of tickets, tasks, and activities that can really be automated using this. Now let's look at this example, right? Uh, Typically, we all are aware that ServiceNow is a ticketing system, and I'm sure you would also have one. So once a ticket gets created, then basically, in normal way, a ticket gets assigned to an engineer. Engineer really works on a ticket, and then possibly we check whether when the engineer really works on it, it resolves it, and then possibly we see that whether this is resolved or not resolved by taking a confirmation from the user. If it is system generated, then you do not have to go to the user, and then you kind of close the ticket if at all it is a user ticket. And then maybe in more mature teams, they also check whether there is a KDB or a known error database that exists for that ticket or not, and then basically resolves it after that. But this was our old way of how to handle the ticket. Right now, if I talk about what can be an evolved way to handle this entire journey, think about that. Basically, a ticket gets generated, and then the ticketing system usually pulls up the ticket. It identifies the correct solution that exists or not, and this ticket correct solution is can be identified by usually look into the way of just give me 1 second. Sorry about that. So if I have to kind of look at this, is that a ticket gets pulled up, and then basically as and when the ticket gets pulled up, then the AI ML algorithm usually checks that whether there is a ticket, there is a workflow that exists to resolve that ticket or not. And why AIML? Because a lot of times your user report a ticket in text format, and hence in order to parse that text, in order to get the right level of information from that ticket, you needed to have an NLP, and you needed to have an NLU triggered. NLP is your natural language processing, and NLU is natural language understanding. ServiceNow also comes in with that feature. And once you do that, then you typically assign the ticket to a script, or rather to, let's say, an asset like Ansible, or maybe an asset like your RPA, and then it executes it. This all is orchestrated by an orchestrating tool like, for example, maybe Aheyu, Rundeck, or Resolve Systems. And then once that is done, then you are using a chatbot asking users for a confirmation that whether this is resolved or not. And then while there is an update that is provided over a chat, or there is an email that is from the user, that gets orchestrated, and then the ticket system gets upgraded. And then typically you get that incident closed. By using this, right, you can identify that there are a lot of things that can achieve. One is your 75% of the time that gets saved for resolving the from the time that you invest into an end-to-end resolution. You save almost, you assign 80% of the tickets automatically either to an engineer or to an automated solution, and hence you save a lot of time. You basically get away with almost 75 to 80% of the tickets, which are typically your password resets and maybe simple category of the tickets, and hence you don't have to invest your engineer time to resolve it. And then the accuracy really increases a lot, right? Because you are feeding back the learning from the system into the system, and then possibly it is becoming more like your efficient engineer who works on the system without getting paid every time. And then like I said, right, that there is a possibility of enhancing this automation, scaling this automation to other categories as well, and hence almost 15 to 20, or depending upon the kind of maturity of your project, it can automate a lot of such tickets, and then maybe help you gaining a lot of productivity gain. So and this is a real example. I mean, this was something which we implemented for some of those clients, and hence I'm pretty confident of these figures. So this is what so I'll take a step back, that we talked about eradicate, and it's easy to remember, and we just need to focus on the first three words: eliminate, reduce, and automate. And we talked about one of the example where we said that always you don't have to kind of jump into a solution, but rather take a step back and see how that solution looks like, and then possibly do a incident tree kind of resolution way, and then identify what should you fix, and then typically think about eliminating first rather than automating first. And then once you can't really eliminate something, we talked about the vulnerability management and the fragmented environments that we all see, maybe common also to your bank. Then you kind of think about how do you create a proactive release management process, where you have a overall view of when would you handle the typical alerts in a specific category, typical vulnerabilities in a specific category, and take an action. And then how do you create a plan of how would you reduce the fragmentation of your environment, and hence make it more simple. And then the last is the automation, where by bringing in a right framework of automation, you can bring in a lot of benefits, and can really save your team from doing the monotonous work over and over again, right? Now comes why toil is necessary, right? And as a lot of you would believe that a lot of times our people who really work on these activities who are really manual, for them at certain point of time the work does not sound really more fun, right? And hence it is something which might lead to a career stagnation, and people might start kind of trying to look out and all that. So hence it is very important that we should really think about eliminating toil as much as possible. and hence ensures that probably people enjoy what they're doing. And then people who are really doing something over and over again, if you go and ask them, then possibly the morale would definitely be would be very less. uh, we have to really work hard to understand what is an expectations from from an individual, and then think about moving the entire culture is with an engineering mindset, right? So that then the people are very very clear that they should think about bringing in more innovation and bringing in thinking about new things, and then the way to kind of solve this is basically the SRE mindset. And then other things like, for example, slow progress sets precedent, promotes attrition, and cause breach of faith are also one of those few of those reasons which really are important for us, and hence eliminating toil is necessary.